Hello, everybody, and welcome to today's presentation, No Silos at the Edge, the Need for Shared IoT Infrastructure, brought to you by Rigado. Before I get started, I'd like to take care of a couple housekeeping items. First off, I'd like to make sure you all can hear me, so if you would, please post a message in the chat panel to let me know. Great. If you have any questions for our presenter today, please post those into the questions panel so we can get to them after the presentation. If you experience any technical difficulties today, like the audio dropping out or the screen sharing not displaying properly, please post a message in the chat panel to me, the host, and I will work with you to resolve those issues. Lastly, on the housekeeping list, we are recording today's presentation, and it will be made available shortly after today's event concludes. Now that we're through the housekeeping items, I'd like to introduce you to our presenter, Kevin Tate. Kevin leads market development for Rigado's edge connectivity and computing solutions. His team works with Rigado's customers and partners to deliver commercial IoT solutions such as asset tracking and smart building. Now I'd like to do a quick sound check for Kevin. So Kevin, if you would, say hello. And audience, let me know if you can hear him by posting a message in the chat panel.
Hey, this is Kevin Tate. Can you guys hear me okay?
Great. And with that, I'm going to turn things over to you, Kevin, to begin the presentation.
All right. Well, thank you very much. And thanks to everyone for joining this webinar topic on no silos at the edge. It's something we think about a lot here at Rigado, the need for a shared IoT infrastructure, especially as we start to see production rollouts across a lot of commercial IoT categories. Let me tell you first how we come at this perspective. Rigado provides gateway infrastructure for commercial IoT. And we are typically working with teams who are deploying large-scale commercial IoT solutions and trying to reduce the cost, complexity, and risk of those solutions. We do this primarily through our Cascade Edge as a Service offering. So we take our gateways and we combine them with secure management and edge computing infrastructure. And we provide these to companies building solutions like asset tracking, which is a very common use case across things like hospitality and real estate and healthcare, smart buildings, where our gateways are used to connect to lots of different devices in a smart office environment. I'll talk a little bit about that. And sensing and monitoring. And these are all places where the combination of Bluetooth and low power wireless connectivity and edge computing at the gateway level is required to bring IoT solutions into the field, specifically in this area of commercial IoT. So, topics for today's webinar. First, I want to talk about why and how gateways are the center of commercial IoT, why today's device up approach that a lot of teams tend to take is creating silos in commercial IoT. And I want to talk about how we're shifting our perspective here at Rigado and share our vision for a scalable, secure, and most importantly, shared infrastructure for these types of commercial IoT applications. So let's dive in. First, a bit about commercial IoT and the specific role that gateways play. So commercial IoT is a very distinct segment of the IoT solutions landscape, and it's different. Different than what? Well, commercial IoT is different than both consumer IoT and industrial IoT. For example, in commercial IoT, we're talking about key applications like connected lighting and asset tracking, sensing and monitoring, and maybe delivering new guest or employee experiences. And those types of applications are being developed and deployed in places like commercial office buildings, retail, hospitality, healthcare, entertainment venues. And this is a relatively recent development. Both consumer and industrial IoT had a head start on this more commercial segment And so the technologies and the infrastructure is playing out a little differently in commercial IoT than it did in those other segments. Specifically, commercial IoT has some opportunities and challenges that are specific to its environment. These are very rapidly growing applications. So things like using Bluetooth or Bluetooth low energy to do asset tracking as an alternative to active or passive RFID is becoming a very popular area of exploration. Similarly, smart buildings are being wired up with occupancy sensors and comfort sensors and guest experiences that rely on a mix of edge connectivity and computing that is unique. And so this market opportunity is exploding, particularly as short-range wireless and edge computing grow quickly. But it requires a different recipe. The type of gateway and connectivity and edge computing at scale that you need to go into every hospital room or every hotel room or every quick serve restaurant is different than what you might put into a automated factory setting or a smart home. And a big part of that difference is the fact that if you're rolling out to literally every hospital room or every quick serve location, you're talking about deployments that are typically in the thousands or even tens of thousands of units. And that changes the cost profile, not just upfront, but ongoing. So there's a relatively distinct opportunity and challenge around these commercial IoT applications. If we look to the left and right at the consumer and in the industrial models, they don't really offer an infrastructure blueprint to work from. In the case of consumer IoT, this is mainly because consumer IoT is relied on phones, right? So starting with wearables and fitness trackers and home health monitors, phones have largely played the role of the gateway. And today we're starting to see home smart hubs start to play that role, right? With all the Alexa devices and the Apple HomeKit devices. But you've got an infrastructure there you can work with. On the other end of the spectrum, the typical architecture around industrial IoT is just too costly and complex for this level of deployment and frankly, the economics of rolling out into commercial IoT. This is just one of many examples. This is an electric smart pipeline reference diagram, but the point here is it's really complicated and rightfully so. If you're managing a smart pipeline, then it makes sense to have multi-$1,000 servers that are controlling the systems and equipment and the data going into that environment. But you just can't afford to do that in, say, every commercial office building or a quick serve restaurant. So a new recipe is required. The good news is we see a common set of edge requirements for these types of applications going into these key segments. And those requirements are, one, wireless connectivity. So you got to be able to connect to a lot of stuff. Two, edge computing. So we need to be able to run apps, collect data, control things locally. And three, the ability to manage those things securely. So that's kind of what's going on with the recipe for commercial IoT, and particularly the role of edge infrastructure as distinct from either consumer or industrial IoT. So how are we seeing companies approach this infrastructure, and where are we seeing that creating the challenge of silos? So in a good way, most commercial IoT architectures look very similar. You've got devices at the bottom, gateways in the middle, and cloud at the top. And this is almost always the blueprint. Types of devices change, types of gateways change, types of cloud services change. But we're also starting to see some standardization, things like Bluetooth 5, Wi-Fi, and mesh, standardizing on the connectivity side, things like containerization, taking hold on the edge gateways, and of course, things like MQTT, brokering the communications with the cloud in a secure way. So we're starting to see patterns emerge, design patterns emerge around this architecture, but it's almost always these three tiers. However, and importantly, we see teams that are working on IoT projects tend to start at the bottom of that stack when they're designing their solution. So they tend to start with the devices. How am I going to gather this data? What type of device or sensor do I need? What's the battery life? What's the range? How can I stick it on something so it doesn't come off? Does it need to be waterproof? So a lot of the initial design and development centers around the actual physical device, which makes sense. It's the manifestation of the IoT solution. Once they've got the devices sorted out, they ask questions about the gateways. Okay, how can I get all those devices connected? What kind of data processing do I need to do? How can I get these gateways connected to the cloud? Maybe I need different ways of doing that based on the environment I'm in. And then finally, okay, how do I push it up to the cloud? And if I'm going to have this many gateways and devices out in the field, how do I start to think about the scalability and security that's going to require, and who's going to do that? Is there an operations team that's going to take care of my edge deployment? So this is typically sort of the architecture path that we see companies take. Again, it makes sense because given that many teams are starting with a prototype, so many of those prototypes start with just getting the devices connected. Unfortunately, they have the effect of driving this device up approach, which has some unfortunate consequences. Because teams are often focused on a single application, they're also typically, we find, looking at just one version of this stack. So they started with, say, devices for, I don't know, monitoring water flow or sensing room occupancy or measuring air quality in a space. And then they build this stack up to the cloud through gateways for a single application. And one of the things we get to see here at Rigado, working with a bunch of different types of companies and their teams, is we'll see 5 or 6 teams sometimes in the same company working on similar stacks, all to go in the same environment, but not coordinating their efforts. They're effectively mini pilots that are happening in parallel, which leads to a bit of pilotitis, where it's hard to get companies to look beyond their stack or silo. But if we zoom back and look at what's really going on in a smart building, and that smart building could be a commercial office space, it could be a retail building, it could be mixed use, it could be any number of things. There's a lot going on. We've got building control systems, we've got employee and guest related systems, we've got security systems, lighting systems, everything you see here. And part of what we're seeing happen is this device up approach is creating a lot of complexity and integration challenges in the context of a smart property. It's worth noting that one of the things that also makes this complicated is, just as there are a lot of systems going on in a smart building, there's a lot of companies involved in a smart building environment like this. Not to mention all the different tenants in that building, but typically you've got different owners and operators and managed service providers for different types of systems. So it's a complex landscape, both from a business and a technical perspective. What this is leading to, though, is individual pilots building their device up stacks to the cloud, all in the context of a smart building, are creating a silo for every different application. And you could fill this chart with 20 different silos, but some of the common ones we see are things like smart lighting, automation of systems and controls, guest and employee, and then safety systems, all with their own sensors and devices, each with their own gateways, and all using different ways of connecting to the cloud. And so this is what we're starting to see both at a company and a building and property level. Worth mentioning that all those different gateways and all those different silos get very expensive, as every gateway needs to be bought, configured, installed, secured, supported. I mean, this is a living, breathing architecture. And so it's often not until a company is truly planning out the rolling of trucks to go run power over Ethernet lines to install their gateways that they stop and say, oh no, I'm going to need to do this, 6 times over the next year and a half if all these pilots happen. I need to be thinking about this with a longer view, because ultimately having a different gateway for every single application just isn't sustainable. And this is a lesson we've learned before. Kudos to Stacy Higginbotham for this picture of all the different home hubs and routers she's got. I saw this on her great blog a couple of weeks ago. If you look at the smart home, it's littered with hubs and routers and IoT gateways, none of which I think make it easier for us to get our devices working together. And we've also learned it in the enterprise context, right? So from an enterprise context, having data silos and system silos have made it hard for all of us to share information and get a single view of the customer and integrate our business. So silos are bad. Look how scary those silos are. Very ominous looking silos. And silos are bad because they're expensive, and not just upfront, but the total cost of ownership goes up with every silo. It introduces significant risk. We could have a whole other session on security concerns, but having multiple silos increases the attack vectors and security landscape to be concerned with. And ultimately, we're creating a fragmented landscape where our data is in disparate systems and it's hard to get that single view of what's going on. Ultimately, I think this could hold back the industry. As we're seeing more IoT pilots finally moving toward large-scale deployment, this is threatening to hold back those deployments as companies realize the challenge of putting in so many different silos in a single environment. So clearly, it is time to freak out. But let us not freak out. Let us shift our perspective. We believe that there is a very logical vision for a shared infrastructure for commercial IoT. The technology is there, but what it requires is for us to shift our perspective on how we look at these types of solutions, and thus shift the role of the IoT gateway in commercial IoT. And that shift is to what I would call a data down view rather than a device up view of commercial IoT. So if we look at the same system from a data down view, we would start with the cloud. So what are all the different data types and elements that need to be collected from this environment? And let's take, for example, a quick serve restaurant. So a quick serve restaurant might be looking at front of house data and applications like guest experiences and point of sale integration and mobile and payment integration. And then they might be looking at IoT applications in the back of house like food safety and monitoring cooking equipment and employee productivity and workflow. So let's look at all of those. And then let's ask the question, why are we gathering this data? What are we going to do with it? And how do we gather it in a way that we avoid fragmentation and that we can manage that smart environment in a holistic way? Then we can ask, what do we need from our gateways? All right, what type of edge computing are we going to need to get all that data where it needs to go? What are all the different types of connectivity we're going to need for downstream devices? And what are all the types of connectivity we're going to need to drive cloud integration? And this is also a good time to ask, as an edge computing infrastructure, where do we need to see local command and control, say being able to turn off equipment if there's a safety issue or notify POS of an important event, versus asking the cloud for command and control that we bring back down to the devices. So looking at the gateways from a data down perspective gives us a way to look at, again, the workflow that we want to create, not just the data we want to push. And then we can look at the devices. And through that lens, it changes the questions we ask about the devices. Sure, battery life and range and size still matter, but so do the opportunity to standardize in-device connectivity. How can we look at, say, Bluetooth and Wi-Fi as ways to serve all the connectivity needs versus ending up with 4 or 5 different standards or custom protocols in a single environment? How can we minimize the number of devices? We might have devices that can serve dual purposes, or devices where we can combine multiple sensors into a single edge device. And then how do we consolidate the installation and maintenance of all that? And really thinking about the coordination of the rollout for instrumentation and control of that environment. So same devices, gateways, and cloud, but a different perspective gives us a different way of planning that activity. And this does significantly change the role that the commercial IoT gateway plays. So if we take this data down view, then we need to have our gateway integrating with multiple cloud services. We need to have our gateway running many edge applications and thinking about how to build, manage, and control those applications in a way that's consistent. And we need to be able to connect to a wide range of devices. And ultimately, having a blueprint for that satisfies not only a single pilot and not only the initial set of applications and devices, but that ultimately is taking a future-proofed view. What are the things we may want to do in that environment? Again, let's say a quick serve restaurant over the next 5 to 7 years. And how do we think about this as the infrastructure on which to gather that data and to deliver those experiences? Ultimately, that evolution is going to require a level of scalability and security so that we can evolve that infrastructure. And that includes things like performance monitoring and updating applications and integrating with the systems that a company uses today to build and deploy new apps and experiences. So that's quite a different view of the role of gateways. It also realistically creates some new demands for a shared infrastructure. So let me show you how that's kind of playing out for us in the companies that we're working with. A good example would be companies that are using Rigado for smart building infrastructure. So in that case, Rigado gateways are connecting to a lot of different types of sensors and building control units. Those are typically coming from a bunch of different types of vendors and companies, and those may be systems that were put in as silos. But now we're able to consolidate those and bring edge applications to them that can control and collect data from all of them. And ultimately, connectivity is often the key point of interoperability there. So a lot of times in a smart building, we'll look to standardize on Bluetooth 5, Wi-Fi, and Ethernet. And a lot of times we're using power over Ethernet there. And we're looking for ways to keep those protocols similar so that we can crosstalk, cross devices, and also offer that sort of future-proofing capability. And so flexible connectivity ends up being a pretty key enabler of this type of shared infrastructure. Another key aspect is the ability to run multiple applications. And today that means leveraging containers to put individual edge applications on top of a common framework and then manage those applications within those containers in a secure and scalable way. One thing that's nice is many companies have standardized on containers for managing their cloud-based applications, and the tools for managing, updating, and securing those containers continue to get better. So in our case, we use Ubuntu Core as our secure container architecture, which allows us to keep the gateways encrypted and manage those containers with over-the-air updates for application and security. Ultimately, taking a containerized approach and running multiple edge applications gives us a framework that isn't unlike the way phones work. So through one lens, we look at our secure and shared infrastructure of gateways as kind of like phones that are in the ceiling, connecting to a bunch of devices, connecting to the cloud, and then running individual apps that can be installed and updated as needed. That's a proven and familiar infrastructure for a lot of companies, and it also fits with the way they're used to developing and deploying applications. So embracing containers at the edge and running multiple applications is really key for this sort of shared IoT infrastructure. Ultimately, manageability will become more and more important as we look at, say, 5 to 7 years of this edge infrastructure in a given space, this is the place where performance monitoring and managing the scalability of that infrastructure, making sure apps are performing well, and that we're managing load across the infrastructure is very important. And then the ability to orchestrate updates. As we've seen companies use our gateways in tens of thousands of different locations, the level of complexity goes up quite a bit as you're rolling out, say, a security patch or a new capability, and you want to be able to do that according to location, time zone, app version. You might even have different types of apps running on the same gateways in different locations. So borrowing from a device, a DevOps style management of update orchestration is important. And then finally, having that type of shared commercial IoT infrastructure really depends on security. And when it comes to gateways, that means you need to both start secure and then stay secure. So the way we do that when we make the gateways, we give a secure key and encrypted ID for a given client to that gateway that stays with the gateway in the field and authenticates each of its initial load, initialization, and updates that come from our cloud-based management tools. And ultimately, a system like that is required to ensure that the apps running on the gateway are what they say they are, and that you're not loading nefarious apps. It's also important to have a way to push new security patches as new risks emerge. There's a lot that changes in the course of a quarter or a year when it comes to edge security. So being able to patch things at an OS level, on a connectivity stack level, is really key to keeping edge infrastructure secure over multiple years. So that's our vision. We believe there's the opportunity to avoid siloed device up IoT stacks that ultimately will cost a lot of money and hold back the industry. And instead, we believe companies can create a shared infrastructure for their commercial IoT applications as long as they're implementing gateways that combine flexible connectivity, the ability to run multiple edge applications, and a way to keep all of that secure and managed over years. And that's our view on no silos at the edge. Thanks very much.
Awesome. Well, thank you. Our first question is, what about mesh? How does that factor into an architecture like this?
Oh, mesh? Well, that's a good question. So ultimately, mesh gives us a way to connect multiple devices as long as there's a density of devices, so they're close enough together, that would rely less on gateways for connectivity. And that's very promising. Obviously, there's mesh around 802.15.4, like Zigbee and Thread, and then there's a lot of exciting stuff happening with Bluetooth mesh and the relatively new spec there. We think that's going to be really key, especially for smart lighting and for sensor networks where you've got a high density of nodes, like, say, I don't know, pallets moving around a factory floor. It doesn't necessarily change the role of gateways, though. You may be able to get away with fewer, which would be great from a cost perspective, but ultimately you need a gateway that's mediating that mesh, running edge applications, and providing the connectivity to the cloud. So we're very optimistic about the role that mesh might play, but doesn't necessarily shift our perspective on the shared infrastructure.
Awesome. Our next question is, do you support HART protocol on Bluetooth?
I'm sorry, could you say that again? Which protocol on Bluetooth?
HART.
The HART protocol?
Correct.
I'm afraid I'm not familiar with that one. I'll have to get back to you on that one. Whoever asked that question, if you want to shoot me a note at kevin.tate@rigado.com, I'll be happy to follow up.
Great. The next question is, how long should a company expect a gateway infrastructure like this to last?
Another good question. It depends on the application, but we typically hear companies talk about 5 to 7 years. Um, and part of our view here at Rigado is that you should expect you're going to refresh that infrastructure, uh, obviously from a software perspective fairly regularly, but also from a hardware perspective. So while you might look at a 5-year horizon, it might be at the end of 5 years, what you're doing is selectively swapping out the hardware to provide new capabilities or to support the latest standards. I think in a lot of ways the best guide here is what we've seen with Wi-Fi. So the type of shared infrastructure that we're advocating for here isn't all that different from the way companies have adopted Wi-Fi in most commercial buildings over the last 10 years or so. But using that as an example, it took a few attempts before we all arrived at a sort of secure, managed, high-performing Wi-Fi infrastructure. And so we'd like to learn those lessons as we look at the infrastructure for commercial IoT.
Awesome. Our next question is, what's the biggest challenge you've seen implementing commercial IoT? And is your approach more open-based on standards under development?
Good question. Good question. Well, we've seen a lot of challenges, but we've also seen a lot of successes. I would say one of the challenges that the second part of the question gets to is closed systems. And beyond just taking a device up approach, a lot of early IoT solutions were very closed. You have to use, let's take a provider of asset tracking solutions, let's say. In order to make everything work, that company had to say, you have to use our specific sensors, you have to use our specific gateways, you have to use our specific cloud tools, and then you can get the data out of our cloud and put it into your cloud. And that, for good reason, that was the recipe in the early days of commercial IoT. I think also for good reason, we're now seeing companies say, I can't be stuck in a single stack, both for economic reasons, but primarily for interoperability. And so they're asking, I think, companies like Rigado for a sort of mix and match approach. I'm going to need to work with lots of sensors. I'm going to need to run lots of applications. I'm going to need to get directly to a lot of different cloud applications. So to the second part of the question, open standards is super, super important. We had the opportunity to speak at the Bluetooth World event just last week, and what we presented on was the need for more open standards and standard profiles for Bluetooth 5 in commercial IoT, specifically so that we can all rely on those and preserve the interoperability.
Great. Our next question is, sometimes IoT projects are driven by device availability with its connectivity options. What are your thoughts on hedging risk by taking data-down view in that case?
That is a very good question, and I am taking for granted here a little bit that the range of connectivity and device options will increase as the market grows. But the question brings up a very good point. There are times where there's really only one type of device or type of connectivity that will suit the need. I'd say where we see that most often is where either size or battery life is a big constraint. We have customers who are expecting 5+ years out of a Bluetooth-based battery-powered device, and in that case, you've got to tune that device and tune your connectivity appropriately. That said, I think that as long as you're sticking with standards, you should be able to use a common set of gateways, or we've seen the ability to use the common set of gateways and edge applications to talk to both highly specialized devices with limited connectivity options and more generally available connectivity options like, say, smart lighting using Bluetooth. So it's a challenge, but I think it still rewards a sort of infrastructure-based view.
Awesome. Our next question is, how many devices or points can be connected via Rigado gateway? Is there a spec for that?
That's another good question. So it depends on how they're connecting. I will say that for Bluetooth-based connectivity, which is often what we're seeing at large scale, if you're scanning beacons, which means you've got devices that are broadcasting data and you're trying to scan that data in an unconnected state, we're able to do thousands of those at the same time. And that's something we pride ourselves on from a Bluetooth performance standpoint. If you are bonding and pairing those connections for individual devices, then it really depends on how you're implementing those connections and what you're doing with those devices. But typically, you're talking about something that's going to be tens of devices in a bonded and connected state, which is why, which I think, again, it's important to look at the overall infrastructure needs and think about that, not just from a range perspective, but from a connectivity bandwidth, because there may be times where people are using bonded and paired connections where something with something that's in beacon or advertising mode may be more scalable for the environment.
Awesome. Our next question is, can you comment on Thread, OpenThread, and your commitment to Thread?
I sure can. We're big fans of Thread. We believe that an IP transport layer that brings IP connectivity in devices and provides interoperability at the IP layer is an excellent idea and would be a key part of the shared IoT infrastructure. We are working with companies on Thread projects today, most of which are still relatively recent. So I think a lot of companies are curious about and leaning into Thread, which is a part of why we support Thread on our gateways, and we support Thread both with our partners at NXP and Nordic Semiconductor. So we're fans. I think as with all standards, it takes a while to go from standard into application and stack development and adoption, but it seems to be picking up momentum.
Great. The next question is, what are realistic cost expectations for this kind of shared infrastructure?
Well, so it depends on how you look at the cost. I'll say from our perspective, in a way that matches this sort of data down or cloud down view, we're seeing companies want to pay for and manage the cost of this infrastructure in a way that looks more like subscription to a service than it does CapEx. And so as a part of that, we offer our Cascade Edge as a service on a subscription basis for about $100 a year per gateway. And that includes the gateway and all the management tools around it. So what we're seeing is companies who want to be able to deploy an infrastructure cost effectively and then scale and grow that as needed. They're looking for ways that feel more like X dollars a year, or in our case, $9 a month per gateway, as a very cost-effective way to start.
Awesome. Our next question is, will the gateway be common for all sort of data collection through different sensors, which includes different modes of communication channels like BLE, Wi-Fi, or 802.15.4?
We believe so, and that's what our gateway supports today, that and a couple of others. I do think that while the hardware and the radios and the connectivity stacks can support all those things, ultimately there is a tax, if you will, to having a lot of applications using disparate communication modes in the same environment. And so as much as I want to believe that interoperability and APIs and abstraction are going to make all that easier, they will, but it's still pretty complicated today. So we encourage companies to sort of pick 2 or 3, not 4 or 5, and look for ways to abstract the data that they're getting from those various communication methods, so they don't have to worry about the connectivity protocol when they're making their business decisions.
Awesome. Our next question is, how would this be applied to a customer that is just getting started with smart sensors, wireless IoT, utility meters, and BAS systems?
Oh, gotcha. Yeah. Well, that's one we're hearing about a lot. And I think, so if we look at building automation or building management systems, those are often the bridge between, say, utility metering and a lot of the energy efficiency opportunities in smart buildings into a category we're seeing grow quickly, which is within those buildings, how do you better understand how space is being utilized or deliver experiences for employees that make them more productive in the workplace. And so we're seeing gateways like ours cast as the glue, if you will, between building management systems and monitoring systems using things like BACnet, and these new low power networks that are gathering data and running applications. So we see it as a really critical opportunity to bring a smart and flexible device into an existing building automation or building management system and significantly extend the capabilities of that system without having to retrofit the BMS. So I think it's a really interesting opportunity. Again, one that benefits from looking at kind of the whole picture for the different applications and sensors you want in that space.
Great. Our last question is, would gateways speak to each other to provide multiple resilient paths?
Ooh, it's a good point. Yes, gateways like to speak to each other. And in fact, we've seen that done a couple of ways. So one way is through Wi-Fi communication between gateways, or mesh-based communication between gateways that ultimately offer some failover and redundancy. Depends on what your backhaul is. So there's sort of two things you want to guard against. One is losing connectivity to the sensors, and the other is losing connectivity to the cloud or the internet. And there's a couple of different ways to do that. But ultimately, looking at this infrastructure as a redundant set of gateways, each with failover modes for both the sensors and the internet connectivity, I think is the right way to look at it and the right question to ask.
Great. Is there anything you would want to add, Kevin, before we close things off?
No, I just want to say thanks for having us, and thanks for all the great questions. It was a real pleasure.
Great. Well, I'd like to thank you, Kevin, for a great presentation today. I'd also like to thank today's sponsor, Rigado, for providing the D-Zone audience with a great webinar presentation. And lastly, thank you to everyone who showed up today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.